Today we are going to be taking a look at how you can create wind sounds using household items. To demonstrate the sound, we'll be using this clip from the survival horror game DayZ. Step 1 is to understand the nature of the sound we are trying to achieve. Wind noise is technically defined by the term aeolian sound produced when the wind encounters an obstacle. Fixed objects such as buildings, trees, cliffs all cause natural humming or constant sounds called aeolian tones. As this definition states, moving objects such as twigs and leaves cause irregular sounds, and this immediately answers the question of why we would want to recreate the sound of wind. The answer is of course because we want this sound in isolation, to ensure its versatility for future projects. Step 2 is to get straight in and record our source sound. This stage involves some experimentation to get things right. I will be using both the ME66 shotgun microphone as well as the Zoom H4n built-in mics to try and capture some suitable source material. After testing out various objects, I found that the best results came from a towel and a feather duster. Due to the nature of these items, I will be driving input gain levels quite high, and it's likely that the noise floor will be significant as a result. However, this is not a concern because it is one of the few situations where noise is actually what we are looking to capture, so a high noise floor actually works in our favour to a degree. Here are some clips containing the original recordings of both. Step 3 was to refine our recordings slightly. For example, I found that a towel on a carpet made a good droning sound, but this would need to be looped, and so a longer recording would be required in order to do this effectively. At the same time, I found that the duster produced a realistic gusting sound, but that the feathers tended to catch on the carpet as a surface material. To combat these problems, I used the duster on a less abrasive rug, and I switched to recording the towel in a longer space. Here are the results. Step 4 is just a quick point about noise and noise reduction. I did test the recordings with noise reduction applied, and I found the difference to be negligible after running the chain of effects that I'm about to show you. It's up to you, but in this case, I think it's just a waste of time. Step 5 then is to load the recordings into a DAW. In this case, I'm using Logic Pro X, and begin by cutting away all of the unwanted sections, leaving us with our final source material. For step 6, I created the loops from my selected regions so that they could be easily utilised later on. My process for looping sounds of this nature is to first select a point within the audio, make a cut, and then move the opening section of audio to the back. I then used a crossfade to mask the newly resulting transition, and this then leaves me with the new start and end points which line up perfectly when looped. Step 7 is to apply effects to the loops to bring the sound together. We start with EQ to take out the unnecessary low end and to locate and cut the extreme high frequency content, which is mostly digital noise. Finally, a 5 decibel boost around 250 Hz gave the sound more strength. Next up is a small amount of chorus, just to add subtle variation to this sound over time. We then add some reverb to try and soften the recording's somewhat sharp edges. Using Logic's Silver Verb, I first removed any frequency cuts and disabled the modulation parameters. Then I experimented with room controls, listening to the 100% wet signal until achieving something suitable. Once complete, we just dial in the mix of wet and dry to taste. Finally then, we employ a low-pass filter to really give this sound its shape. This is where everything really comes together. As you can see, I have the filter resonance set at 25%. This, together with the cutoff parameter, is arguably the most important factor in the signal processing chain. As you can hear, the resonance is giving the sound that whistling effect, due to the sharp boost in frequencies around the cutoff point. It is best to experiment with your filter before committing anything, as you will find that you can really alter the character of this sound depending on the relationship between these two parameters and how you control the cutoff itself over time. Changing the cutoff too quickly or going too high or low will break the illusion of a natural sound. You will find that you don't need to sweep across large sections of the frequency spectrum in order to replicate natural wind noise. The final step, step 8, is to layer the sound. I've taken the recording of the feather duster and applied the same chain of effects to it with slightly altered filter cutoff and resonance parameters. In theory, you could layer many more recordings to create depth to the overall sound, but just remember that this is essentially noise, and so there will be a point where the details captured in the recordings themselves get lost. It's all about finding that balance and experimenting over the main points of this process. After both layers were completed, I dropped them onto the clips, and here is the result with some footsteps thrown in as well. Bear in mind there's a lot still missing from these clips, but I've left it as is to keep focus on the wind. I really hope that you enjoyed this video and that it helps you in your current project. If you have any questions, comments or requests, you can leave them down below, and I'd really appreciate it if you could leave a like on the video if you enjoyed this content. Thanks for watching.